Good morning. Myself, Dr. Dhane, here with introducing a chapter that is under the syllabus of Pharmaceutical Organic Chemistry 2, and in that I am going to cover unit number 2, that is Introduction to Phenol. Now, this particular presentation is prepared by myself, that is Dr. Dhane, and it is approved by the principal, Dr. C.M. Jangme sir. Now, the objectives and the contents of this presentation is, today I am going to cover objectives. Now, what is the meaning of the word and the organic compound, that is phenol? Acidity of phenol. Effect of substituents. What happens if the substituents are changed on the acidity? The identification test for the qualitative test of the phenol. Then some of the examples of particular phenol derivatives, that is cresol, resorcinol, naphthol, and the significance and uses of the phenols. Now, the objectives and the course outcomes of today's lecture is, at the end of the lecture, students will be able to identify the structure of some of the phenolic compounds, and they are able to describe the physical properties of the phenol. They are able to describe methods to synthesize phenol and its derivative. They are able to describe the acidities of phenol and effect of substituents, and able to compare the acidities of particular phenol derivatives with the aliphatic alcohols. Then some of the structure and uses of phenol, cresol, and naphthol derivatives. Now, what is actually a phenol? Phenols are the molecules. They have a hydroxyl group which is attached to the carbon atom of the aromatic ring. Now, in phenol, the hydroxy functional group is directly attached to the sp2 hybridized carbon atom of the benzene ring, and the introduction of this hydroxyl functional group at the unhybridized 2p hybrid orbitals of the benzene ring. Now, phenol. Sometimes phenols compounds are called as phenolics because this is a class of chemical compound in which the hydroxyl group is directly bonded to the aromatic hydrocarbons, and the structure we are going to get is, because we are going to substitute one of the hydrogen atom of the benzene, so we are going to obtain C6H5OH is the particular structure of phenol molecule. Now, the nomenclature patterns of the phenol. Phenols are nominated by two methods, that are common nomenclature system and the universally designed IUPAC nomenclature system. Now, some of the substituted derivatives of the phenols are cresol. Now, depending upon the substituent is at what position, the substituted phenols are categorized as. If the methyl group is substituted in the phenol at ortho position, the name of the compound is orthocresol. If it is at meta position, then metacresol and paracresol. So these are some of the examples of the substituted phenol derivatives. Now, the nomenclature patterns of the phenol. Phenol are the derivatives. They are named by their common names. We can nominate them as an phenol, substituted phenols at ortho, para, and meta positions. Then some of the examples of the phenol derivatives are hydroquinone, then 2,4,6-trinitrophenol. We are nominated them as a derivative of phenol, that is picric acid. Now, these are some of the structures of substituted derivatives of the phenol, that are catechol, resorcinol, hydroquinones. If the two benzene rings are fused together in the linear pattern, and if the hydroxyl group is substituted at one of the ring of the benzene ring, then we are going to get a derivative of phenol, which is a fused ring of the two benzene rings, and the name of that compound is 1-naphthol, or we call them as an alpha-naphthol. And if it is at beta position, then we are going to nominate that compound as a beta-naphthol. Some of the physico-chemical properties of the phenol. We can nominate this phenol derivative in terms of IUPAC nomenclature system, that is a benzenol. Some of the common names and other names are there for the phenol derivatives are carbolic acid, then phenolic acid, hydroxybenzene, The molecular weight of the particular phenol is 94 grams. It is a basically transparent crystalline solid and going to have a sweet and tarry taste. The boiling point of a normal phenol derivative is 181 degrees centigrade. So these are the some of physico-chemical properties they are there going to possess by the phenol nucleus. Now, what is actually a phenol? This is a pure crystalline solid and basically it is used as an disinfectant. We have to handle this phenol with a great care, and because if you are going to handle it with the rough use, there are some appearance of the white blisters on the screen. So we have to handle this phenol nucleus very carefully. Solubility, when we are talking about the solubility, phenols are moderately soluble in the water. That is, about 8 gram of the phenol can be dissolved in the 100 grams of the water. So there are grades of the solubilities. So depending upon that, about 8 gram if it is soluble in the 100 gram of water, we can categorize the phenol. It is a moderately soluble. Phenol is somewhat soluble in water because they have the ability, as they have the presence of hydroxyl functional group in its structure, they have the ability to form the hydrogen bonds. And as we all know, if the compound is going to form the hydrogen bond, he has a solubility in the water. When we are talking about the main and important property of the phenol, phenols in the aqueous environment or the aqueous medium, they are going to behave as an weakly acidic property. Now, we all know what do we mean that acids? Acids are the compound if they are able to donate the hydrogen bonds, that means a proton donor, we are nominated that phenol compounds as an acidic compound. Similarly, phenol in its aqueous environment or aqueous medium, he able to and he donates is a proton, so behaves as a weakly acidic compound. And after donation of this hydroxyl groups in the aqueous medium, whatever derivative or whatever the ion formed by the phenol derivative, we are nominating that ion as an phenoxide ion. That means when phenol dissolved in water, it is going to produce H plus ion plus intermediate or the unstable ionic compound, that is phenoxide ion. Some of the chemical properties, that is we have discussed. When we are going to compare this acidity, that is phenol, if it is dissolved in water, he is going to behave as an acid. And when we are comparing this acidity with our aliphatic alcohol, when we are comparing this acidity with aliphatic alcohol, phenols are going to behave as a strong acid than the aliphatic alcohol because they are readily able to donate the proton and able to produce phenoxide ion as compared to the aliphatic alcohol. So the property of donation of H plus ion in the aqueous environment is more as compared to the aliphatic alcohol. So when we are going to compare the aliphatic alcohols with the phenols are behaves as a strong acid than the alcohols. Now, the acidities of phenols are more than the aliphatic alcohol. Now, this formation and acidities is due to immediately and able to donate the H plus ion. Now, these are the slide is reflecting some of the resonating structures of the phenol. As we all know, phenol is nothing but the attachment of the hydroxyl functional group to the benzene ring. When a phenol nucleus is going to donate his H plus ion, the remaining phenoxide ion is going to be behaves as a strong electronegative atom. Now this strong electronegative atom and this phenoxide ion is unstable in nature. He ability and he immediately donates his electron to the adjacent carbon atom. Likewise, as the phenoxide ion is nothing but a compact structure of the benzene ring and attached to oxygen, that is electronegative atom. The moment H plus ion is detached from the phenoxide ion, this oxygen atom donate his lone pair of electron to the adjacent carbon atom. Now due to which the system of compact nature of the benzene ring is disturbed and the phenoxide ion able to form its resonating contributing structure. So the slide is reflecting here some of the resonating structures of the phenol nucleus. Now, just now we have talked about the acidity pattern of the phenol. Phenols are strong and more acidic than the alcohol because they are immediately able to donate the H plus ion as compared to the aliphatic alcohol. As the acidic nature of the phenol is due to, in last slide only we have discussed that due to the formation of the phenoxide ion, he is able to form or he is able to give the resonating contributing structure. The more will be the resonating contributing structure, more will be the stability. So in terms of this, the resonance stabilization of the phenol is more as compared to the resonance stabilization of the phenoxide structure is more as compared to the phenol. So when we are going to compare a phenoxide ion with the phenol, phenoxide ion is more stable than the phenol molecules. Now, in terms of other words, we can say the presence of electron withdrawing group in the benzene ring increases the acidity of phenol, whereas the presence of electron releasing group decreases the acidic property which is shown by the phenol nucleus. Now, these are examples of some of the phenol derivatives with their pKa values, that is acidity constant values, the substituents which are there on the ring, and what type of effect shown by those substituents in those phenolic derivatives. Now, for example, if the substitution of the methoxy group in the structure of phenol, we are going to get the positive mesomeric effect and negative inductive effect. So similarly, depending upon the type of substitutions, the effect of substitution it's vary in the structure of the ring. Now, as we just now discussed some of the derivatives of the phenol, these are some of the, as we have discussed in the last slide, the resonating structures of the phenol. Similarly, these are some of the derivatives and their resonating contributing structures. For example, a resonating contributing structure of cresol. In this case also, cresol being a phenol derivative, he is also going to behave as an acid, immediately donate its H plus ion, and due to the presence of this oxygen as an electronegative element atom, he is able to pass his negative charge on the adjacent carbon atom. So basically, 4 resonating structures are produced by the cresol nucleus. Similarly, when we are talking about the substituted nitrophenol derivative, they are also able to form the 5 resonating structures. Again, when we are talking about the resonating structures of dinitro substituted phenol derivatives, the dinitro, due to the substitution of the nitro group, the stability pattern is increased and he is going to form basically 6 resonating structures. That means 2,4-dinitrophenol is more stable than the 1 substituted para-nitrophenol. Now, the next point which we are going to discuss is identification and the confirmatory test for the phenol, because this is there in the syllabus. Now, how come we are going to identify whether the presence of phenol nucleus is there in the given unknown structure of the compound? For that, we have a ferric chloride test, in which what happened in the case of ferric chloride test, the compounds containing phenol group able to form a variety of colored derivatives or the colored compound when they are going to be react with the aqueous ferric chloride solution. So the aqueous ferric chloride solution react with the phenols and they are going to form a colored compound derivatives depending upon the concentration and the intensity or the reactivity pattern of that phenol. So what type of color they are going to produce? They produce blue, violet, purple, green and a variety of compound derivatives when they are going to react with the ferric chloride solution in the presence of pyridine base as a solution. Now, the procedure for this particular test is phenols 15 gram of a known compound, because we don't know whether the phenolic compound or presence of phenolic compound is there, in which we are going to add a small traces of water, that is 0.5 ml, and 1 to 2 drop solution of 1% aqueous solution of the ferric chloride solution, that is iron chloride solution. And the observation, if the presence of phenolic functional group is there, we are going to get the categories of colors, that is red, blue, green and purple color is produced depending upon the concentration and the concentration of the phenol nucleus present in the given structure. Now, particularly we have discussed what are actually phenols, the acidity patterns of the phenol, effect of substituents on the acidity of phenol, whether electron donating and electron withdrawing groups are going to increase or decrease the acidity pattern of the phenol. Later on we have discussed some of the resonating structures, their contributing structures for cresol, nitrophenol derivatives and dinitrophenol derivative. Now we come to the point that what are the uses of these phenolic type of compounds. They have their own uses in the pharmaceutical industry as well as in the cosmetic industry. Like, phenolic compounds are used to prepare in the manufacturing of the plastic industry. Phenol is going to form a polymer with the formaldehyde compound, and it is commercially used to prepare a phenolic resins. This is also used in the study of extraction of some of the biomolecules from the herbal compounds. Then this is also used in the cosmetic industry for the preparation of some of the sunscreen like preparations, then skin lightening creams, and also for the formation of compounds like hair coloring solutions. They are also used as a precursor for the collection of large amount of the drugs, synthesis of high throughput screening, and basically and the main use of phenol is for the synthesis of aspirin as well. It is also used in as a precursor for synthesis of most of the pharmaceutical drug products. So these are some of the important uses of the phenol and its derivatives. Now we are going to discuss some of the compounds and the derivatives of phenol, their structure, the physicochemical properties and uses. So first derivative of phenol that we are going to discuss is a cresol molecule. What is cresol actually? Cresols are basically a methyl phenol. Now, depending upon whether this methyl group is substituted, whether it is at ortho position, meta position and para position, we are nominating that cresol molecules as orthocresol, metacresol and paracresol. Now, these cresol compounds are widely occurring in the natural and manufactured groups of most of the organic compounds. They have their own uses and used as a disinfectant to prevent the corrosive effect of the protein. So these are some of the applications of the phenol, and the picture he is going to reflect here the structure of orthocresol, metacresol and paracresol compound, that is depending upon where this methyl group is substituted. Now, what are the uses of these cresol compounds? Depending upon the presence of methyl group, whether it is at ortho position, para position or meta position, varieties of uses are there. But the common uses, they are used as a disinfectant, solvent, likewise. Now, the first compound, that is orthocresol, is used as a solvent, as a disinfectant and as a chemical intermediate for synthesis of varieties of compound. The use of metacresol is used to produce some of the herbicides type of compounds like parathyroid insecticides. Then the paracresol molecule is used to form the antioxidant in the fragrance and pharmaceutical and dye industries. They are also used for the synthesis of pharmaceutically important synthesized compounds like carbachol, toliprolol, tolamolol, and it is also used for the synthesis of very important antioxidant compound, that is butylated hydroxytoluene, which we are going to use for the study of most of the antioxidant compounds to study the antioxidant properties of given unknown compound. This particular compound is used, that is butylated hydroxytoluene, and for the synthesis of this butylated hydroxytoluene, phenol is used as an precursor molecule. So next compound from the same phenolic derivative is a resorcinol. What is this resorcinol? This is actually a dihydroxy benzene derivative, and the presence or the position of the hydroxyl groups which is there on the benzene is at first and third position. So the particular IUPAC norm of this resorcinol compound is benzene 1,3-diol, for which the common name is resorcinol or resorcine, having a chemical formula C6H6O2. Now, this resorcinol compound is used as an antiseptic and disinfectant. The 5 to 10% solution are used in the treatment of chronic skin diseases, as well as it is used in the treatment of gastric ulcers. A 2% solution of the resorcinol solution is used to treat the vaginal and external vaginal infection, as well as the presence of this resorcinol as a constituent in the preparation of skin protectant teams and for the preparation of topical analgesics. It is also used for the production of the diazo type of dyes, as well as resorcinol is going to have its own application in the plastic industry. Then for the preparation of phenol resins, it is used as an analytical grade reagent for the determination of presence of ketoses type of sugars, that is fructose. For that, Sullivan's test is designed, and the Sullivan's test is going to have the presence of resorcinol is one of the ingredient or the chemical reagent for the identification of the fructose. What type of monosaccharide sugar is there in front of us that we can identify with the help of Sullivan's test. Resorcinol is going to have the reaction pattern with the formaldehyde to form or to synthesize the thermoset resins, and which can be formed on the basis of frozen smoke. So for the synthesis of the Sullivan's test aerosols, we can use a resorcinol nucleus, which is actually a dihydroxy benzene derivative. Our next compound, which is there as a phenol derivative, which is prepared by using a naphthalene nucleus. Now, what is naphthalene actually? Naphthalene is a condensation or the fused two benzene rings which are there, and this fused benzene rings, if they do have the presence of one of the hydroxyl functional group at first position, the compound which is to be nominated or the synthesized compound is known as alpha naphthol, and the presence of this same hydroxyl group, if it is at second position, the compound is nominated as a beta naphthol, or we can nominate them as a 2-naphthol. Alpha naphthol is nominated as a 1-naphthol and beta naphthol is nominated as a 2-naphthol. Now, what is this naphthol actually? This is a fluorescent colorless crystalline solid which is going to have its two isomers. Naphthols are going to have two isomers, that is alpha naphthol and beta naphthol. They are differing due to the location of the hydroxyl functional group which is there at first position or the second position. Now, some of the methods of preparation of phenol. How these phenol compounds are synthesized in the laboratory scale, or how we are going to synthesize these phenolic compounds. For that, various methods they are adopted for the formation of phenol compounds. From the starting material, that is chlorobenzene, then from the air oxidation of the cumene nucleus. Then the third method for the preparation of phenol is from the hydrolysis of the diazonium salt, and for this alkali fusion of sulfonate. So the first method, that is from chlorobenzene synthesis of phenol, is basically known as Dow process. Now, where we are going to react this chlorobenzene with an aqueous solution of the sodium hydroxide at a temperature, that is high temperature, high degree centigrade temperature, that is at 360 degrees centigrade, as chlorobenzene is going to be react with a strong base with to that higher temperature, that is formation of an sodium phenoxide derivative. Now, this sodium phenoxide to be neutralized with a dilute acid like hydrochloric acid. In order to remove this sodium ion, we are able to get the phenol through a reaction involves a nucleophilic substitution of the or the replacement of the chloro group from the chlorobenzene. We are substituting or we are replacing the hydroxyl functional group, which is donated by the strong base, that is sodium hydroxide. These conditions are not, we cannot obtain or we cannot perform these conditions at the small laboratory scale, but this is one of the method earlierly used for the synthesis of phenol, that is from chlorobenzene, and it is also known as a Dopp process. Second method for the synthesis of phenol is air oxidation of the cumene. Now, what is basically actual this cumene? This is also known as isopropyl benzene, in which this method is particularly have its own importance for the synthesis of phenol, and we are starting this method from the use of cumene, in which cumene is converted by air oxidation into the cumene hydroperoxide, and which is again converted by the reaction with the aqueous acid into the phenol derivative. So first of all, air oxidation of cumene, and then cumene through a hydroperoxide derivative, it is immediately converted to the phenol nucleus. Third and very important method having its versatile application in the synthesis of phenol is hydrolysis of this diazonium salt. Now, what is basically a diazonium salt? When we are going to react any primary aromatic amine with any mineral acid, the compound which we are going to produce is name of that compound is diazonium salt, in which the aromatic compound have the presence of two nitrogen atoms which are doubly bonded to each other. Now, this ArN2 belongs to a diazonium salt, and simply hydrolysis of through a hydrolytic procedure of this diazonium salt in the presence of water, we are able to obtain or we are able to produce a phenol derivatives, and the nitrogen atom is released in the form of gas. So the first derivative or the diazonium compounds which we can use for the formation of a phenol derivative, that is, for example, we can use a chlorobenzene diazonium sulfate salt. Simply undergone the hydrolytic procedure in the presence of mineral acid and water, we are going to produce a substituted phenol derivative, that is metachlorophenol. So likewise, we can use any diazonium salt, and if we are going for the simple hydrolytic procedure, we are able to produce a listed compounds which are phenol in nature. So this is very easy and very versatile or used important method for the synthesis of from the synthesis of phenol from the hydrolysis of diazonium salt. Fourth and very important method used for the formation of the phenol is alkali fusion of the sulfonate salt, in which the benzoyl sulfonic acid is going to be react with a strong base, that is sodium hydroxide. So we are able to produce the sodium peroxide, and which is when react with the sulfonic acid, we are able to get the derivative of the phenol, that is naphthol, from which 2-naphthalene sulfonate we are going to produce a substituted sodium 2-phenoxide, and ultimately through a mineral acid treatment with a dilute sulfuric acid, we are able to synthesize a beta-naphthol derivative. So these are 4 methods for the synthesis of phenol, that is number 1 from the chlorobenzene, number 2 through air oxidation of the cumene, number 3 simply through hydrolytic procedure of the diazonium salt, and 4th is alkali fusion of the sulfonates in the presence of strong base at high temperature. The particular sulfonate derivative is going to produce a phenol derivative. Reactions of the phenol. As we all know, phenols are going to behave as an acid able to donate proton in the presence of water, That means the compounds which are able to donate the proton, they are going to produce a proton. Immediately they will donate their proton and produce a phenoxide ion. So phenols behaves as an acid. The property that possessed by the phenol as they are going to behave as acid when they are going to react with the base. The main important property or the property shown by the phenol compounds is they are able to form the salt immediately when react with the base. So the salt formed by the phenols when they are going to react with the sodium hydroxide is sodium phenoxide. Next important reaction shown by the phenol nucleus is ether formation. Now when phenols are going to react with the alkyl halides, any alkyl halide, they are able to produce a ether derivative. And the moment when we are going to use phenol with the alkyl halide, they are able to form ether. This particular method of synthesis of ether is known as Williamson synthesis, in which phenol first of all shows his acidity property, that is able to donate proton, and formed phenoxide ion are again reacting with the alkyl halide derivative. In the presence of strong base and heat, phenols are going to form the ether, and this formation of ether from the phenol nucleus, this method is known as Williamson synthesis of ether. Then phenols also going to have a reaction, that is formation of ester derivatives when they are going to be react with the acyl chloride derivatives. So for example, when phenol react with the benzoyl chloride, they are going to form the phenol benzoate, and likewise the ester formation reaction is proceeding. Phenol is also undergone for the ring substitution reactions like nitration, sulfonation, Friedel-Crafts alkylation, Friedel-Crafts acylation, nitrosation, and aldehyde formation. So these are some of the important reactions shown by the phenol due to its ring substitution reaction, in which the hydroxyl and oxy group activate powerfully and direct the electrophilic substitutions at positions like ortho para in electrophilic aromatic substitution type of reactions. And when the alkyl substituted phenol is there, they are less powerful than the phenol. So when we are talking about the phenol is going for the nitration reactions, the nitro group is substituted first of all at ortho position and subsequently at para position. That means phenol is going to produce ortho and para substituted derivatives if it is undergone ring substitution type of reaction. So subsequently nitration reaction produces orthonitrophenol, sulfonation reaction is going to produce orthophenol sulfonic acid or paraphenol sulfonic acid. Through Friedel-Crafts alkylation reactions, the alkyl group is substituted at the para position of the phenol nucleus. Now, phenol is also undergone for the Fries rearrangement reaction, in which resorcinol is going to be react with the carboxylic acid derivative, and they are able to form the ketone compounds. So from the carboxylic acid derivative, we are able to synthesize one more carbonyl compound, that is ketone derivative. This type of Friedel-Crafts acylation reaction is known as Fries rearrangement. Phenol is also undergone for the procedure of formation of aldehyde from the phenol nucleus, and this formation of aldehyde derivative from the phenol by simply using an organic solvent, that is chloroform, in the presence of strong base, that is aqueous solution of the sodium hydroxide. Phenols have the property to form the aldehyde, that is salicylaldehyde. This particular formation of the aldehyde compound from the phenol is known as Riemann-Tiemann reaction, in which we are going to obtain the aldehyde compounds. Now, throughout this class, we have discussed about what are actually phenols, the acidity patterns of those phenol derivatives, what type of effects they are shown by if they are substituted with the electron withdrawing or electron donating groups, the qualitative test used for the identification for the presence of phenol, and some of the examples of the phenols, their structure, uses like cresol, resorcinol, and naphthol derivatives. Thank you.